you are going to watch an experiment to study the characteristics of ZENER diode. Welcome back to my physics classroom. This is the device for studying ZENER diode characteristics. We have a ZENER diode connected in forward bias mode. Forward bias means the positive of the diode is connected to the positive of the battery and negative of the diode is connected to the negative terminal of the battery. To change the voltage between the junctions of this transistor, we can adjust this knob. There is a voltmeter to measure the voltage between the junction, and to measure the forward current we have a milliammeter. To study the forward bias characteristics, first we have to change the voltage values and note down the corresponding forward current value. So let's start with 0. When the voltage is 0, there is no deflection in the milliammeter. That means forward current IF is equal to 0. Now keep the voltage value to 0.1. This is a 0.1 volt. So you can see the divisions: 0.2, 0.4, 0.5, 0.6, 0.8 like that. So 10 divisions are equal to 0.2. So the 5 divisions will be equal to 0.1. So I am keeping the needle at 0.1 volt. For 0.1 volt, see the corresponding forward current IF value. IF value is 0. So note down the value in the tabular column. Now slowly increase the forward voltage to 0.2 volt and see the milliammeter. So forward current IF is a 0. There is no change, no deflection. Now increase the forward voltage gradually to 0.3 volt. There is no change. 0.4 volt, no change. 0.5 volt, no change. So we have to note down the forward current values as 0 only, because there is no change in the milliammeter. 0.6 volts, then there is no change. So 0.6 volt also, the corresponding forward current IF is equal to 0 milliampere. 0.7 volt. So when I am keeping the voltmeter at 0.7 volts, so we have got the deflection for 2 divisions. Here 10 divisions are equal to 5. So 2 divisions will be equal to 1. So the value will be 1 milliampere. So forward current is 1 milliampere. I am increasing from 0.5 volt to 8 volt. So you can see here, let's see, 0.8 volt, and here, so 7 divisions are there after 10. So 1 division is equal to 0.5. So there will be 13.5 milliampere. Let us do the calculation part for forward bias characteristics. So we have the tabulated readings for VF and IF. Now we have to draw a graph by taking VF along x-axis and IF along y-axis. So you are getting a graph like this. In the graph, you are seeing up to 0.6 volt, there is no forward current. That is because of the barrier potential of the ZENER diode. When the forward voltage is increased beyond 0.6 volts, we are getting forward current. Forward current gradually increases, and after 0.7 volts, it exponentially increases, the forward current. So the 0.7 volt is called as knee voltage. So you can mark the knee voltage in the graph. Now we are going to find out the forward resistance of the diode. For that, you have to take a slope. For taking slope, draw two horizontal lines from y-axis and two vertical lines from x-axis, and those four lines will meet the curve at some points. Now, measure the distance between the lines in x-axis and y-axis. So, we will get dy and dx. The slope equal to 2 milliampere by 0.03 volts. Forward resistance is calculated by using the formula 1 by slope. So, that is equal to 0.03 volt divided by 2 milliampere. We have to do the calculation in SI units. So, change the milliampere into ampere by multiplying 2 milliampere by 10 power minus 3. So, we will get 2 into 10 power minus 3 ampere. So, 0.03 divided by 2 into 10 power minus 3 ampere will give us a value of 15 ohm. That will be the forward resistance of the given diode. To study the reverse bias characteristics, we have this ZENER diode connected in reverse bias mode. In reverse bias mode, negative of the diode is connected to the positive of the battery, and positive terminal of the diode is connected to the negative of the battery. And we have a voltmeter VR to study the voltage between the junction. To study the reverse current, we have a milliammeter. So first we will increase the reverse voltage just by turning the knob. So I am turning the knob. So I am keeping the voltage at 1 volt. There is no deflection in the milliammeter, so no current flows. Okay. Now I am changing the value to 2 volts. The reverse voltage, there is no change. 3 volts, there is no change. 4 volt, there is no change. 5 volt, there is no reverse current. Milliammeter shows 0 deflection. And 6 volt, still no current. 7 volt, and I give 7 volt. The current slowly increases, and I am still increasing the voltage beyond 7 volt, but the voltmeter shows only 7 volt. The voltage stays same, but you can see the gradual increase in the current value. Now let us draw the reverse bias characteristics curve. For that, we are having the tabulated readings for VR and IR values. So take VR along negative x-axis and IR along negative y-axis. So you are getting a graph like this. Afterwards, when the reverse voltage is increased beyond 6 volts, say 7 volts, we are seeing a sudden rise in the reverse current. So you are getting a graph almost straight line you are getting. That is because of the breakdown of the junction. So the 7 volt is the breakdown voltage for this ZENER diode. I hope you understood the process involved in studying the characteristics of ZENER diode. I will meet you all in another video with yet another demonstration. Till then, bye bye.